Hey guys, welcome to my last recording for the basic drawing course. Today I just want to go through some of the structural steel that you'll be learning with me next semester. So I just want to touch base on it now so it's not all new, and then next semester when I teach you the course we'll go a lot more in depth in it. So in Revit, obviously I'm going to go new, I'm going to create a new structural project and go OK. So we're going to come straight away to our level 1. I'm going to create some grids. So we create grids here. When we do structural drawings, we always draw along grid lines. So just draw some grids, doesn't really matter where. Let's span this at 7 meters. Another one up. Alright, so I get 1 and 2 up the top. Now I'm not going to put 3 and 4 down the side because it gets a bit confusing. So what I do is I create another grid through here, escape out of it twice, double click on it, and I change this to A. So generally we'll have numbers and letters. Then when I create another grid, let's say 5 meters, Revit will change it automatically for me. Just tidy these up, so I click on it and drag it up. And that's how we just set up our grids. So in structural drawings or structural drafting, we set up grids and then we set up our levels. Alright. For now we're not going to worry too much about this because we're just trying to understand how it all kind of comes together. So what are we going to do first? Well, let's put in some steel. So structure, let's put in a column. Alright, so at the moment I got a concrete column. Let's put in, it's got 250 UC for now. And I can put them in on the grids. If I hover over it, I can go spacebar, we'll rotate it around. So I'm going to span it to go this way. So one here and one here. Escape. Let's put some more columns in. Have I got any SHS in here? Nope. So let's load family. Australia, structural columns. Steel, Australian standard, and let's have a look for our SHS. So I've got different grades of steel here. Let's go for a 350. Let's go open, and let's take a, what's a good one? Let's go 89 by 89 by 5. Go OK. Alright, so let's put them at these intersections. Alright, so in these drawings, everything is always referenced in grids. And while we're here, I'm just going to show you, usually we don't do, like for steel, we can do the calcs by hand. It's not too bad, it's pretty quick. But generally you use design spreadsheets. So I have mine here for beams. This is my steel beam design spreadsheet. I can put all my loads on it, work out my combinations, get all my span of depth ratios and deflections, so my serviceability criteria, and then work out the actual capacities of the beams, and then it's going to punch out and tell me what beam I'm going to use. You will learn all of this in your structural analysis course, and obviously I have all my beam properties here. For my columns, I have another one here for SHS, so if I want to use, so we're using the 350 section, it's the properties here. If I want to use, what was that, 89 by 89 by 5, so that one, what I can do is I can now increase my load, so I got 100 kilonewtons, so load acting on it, my height of the column, a couple of factors, a little bit of an offset, and then a bit of a calculation here, and then I get all of my capacities, so checks, adequate, checks, adequate, checks. Alright, so this beam, or this column, is okay for this load. Alright, if I increase it to say 200, adequate, adequate, not adequate. So it fails in 2 different criteria. So go find a bigger column. Alright, you'll learn all of this in your structural analysis, but just showing you where these come from. So back to Revit. So I've got my columns in here. But what I haven't done is I haven't set any of the properties for them. So let's select them all. what I can see is my base offset is at level 1, and then I have a negative, sorry, my base level is level 1, and I have a negative offset here. So it's sitting below the ground. If I look at my 3D, that's what I expect to see. Is from level 1, it comes down. What I want is I want it to come from this level to this level. So to change them, alright, let's come back here. Let's grab these columns. So I want the top level to be level 2, and I want a 0 offset. Apply, and now they're sitting where I want them to sit. So in the 3D, what I'll do is I'll just change it to shaded, and I'll turn off my analytical model, and these are the columns that we've put in. So we've got 2 UCs and 2 SHS. All we're going to do is going to create a frame spanning this way, frame spanning this way. Alright, that's the goal for today. And then in structural drafting, we're going to go very much so in depth with these things. So let's come to our level 2. Alright, I'm going to put the beams up top. So beam 310 UB will be okay. So from this midpoint to this midpoint, escape, and then this midpoint to this midpoint. Alright. So I've got a beam here. Look at my 3D. I've got a beam through here and a beam through here. I know we're going very quick. This is just a very broad overview. So please try your best to follow along and pause as you go. Like I said, you've got an entire 18-week course with me going very in depth with these things. So I've got these sitting here now. Alright, so I have to connect them somehow. We're going to do these connections in a second. We're just going to put a concrete pad down the bottom to kind of finish these off a little bit. So back to my level 1. Let's put in an isolated foundation. Now this pad footing is probably a bit big. Again, spacebar spins them around. So let's edit type, duplicate. Let's make one, say 1200 by 900 by 400. So thickness 400, width, and then length 900. Doesn't really matter because we can rotate it. Go OK. So it's up to me which way I want it to go. Let's put one here. Let's put one here. The other thing you can do is isolated wall. I can pick this at grids here and just select the grids I want it to go to. What it will do is it will find where 2 grids intersect and it places the object there. Finish. I've got my pads in there now. Alright, to our 3D. So I've got some concrete down here. Alright, so load acts on the beam. Half of the load comes to the column. The load comes down the column to the pad, from the pad to the ground. Alright, so the pad just spreads the load out. This is a point load. Alright, it's very small. It then distributes it over a larger area. Then distributes it over a larger area. Alright. Okay, so let's put in some connections. So connections are a bit different in Revit. We have to actually load them in. So at the moment there's no connections here. So let's click this connection settings. When Revit decides to load. Cool. So these are all the connections. So they're available. These are loaded. So nothing's loaded in. So let's go all and let's go add. So it loads them all in. Go OK, and now I can access them. So to connect them, select what you want to connect, hold Control, so you get the plus over the cursor, and what do you want to connect it to? So select the 2. So I want to connect the beam to the column, then come up to structure and go connection. You get this funny thing here, that's just the generic connection. So you have to actually pick a connection that we want. So I have many different connections now loaded in here, and I have to pick. So just zooming in. Alright, we have to be careful with SHS. Obviously I can't bolt in the middle there, so I kind of have to weld to the front face of it but I can bolt through the beam here. So what we might do is, have I got a shear plate? So we use a shear plate. Alright, something like this. Cool, and that's what you can see. Alright, very impressive. Alright, doesn't really make a difference. The reason for that is the detail level needs to be fine to show the connections. This is the plate, so they'll weld the plate to the SHS, then they'll bolt through the beam here. Alright, we can select on the connection, override it, and then modify it. And in here we can then come through, alter our beams, alter the plates. We can cope the beam like this. Obviously all the numbers relate to this. We can add in stiffness, we can change our bolts, where they sit, how they're sitting, any gaps or construction gaps of 10 mil that we want, and all of that we can put into here. But you'll learn all of that in your structural drafting course with me. Alright, so next thing we do is we right click, we go propagate connection. What it's going to do is going to find every spot in the project where I have an SHS meeting the same beam, and it's going to place another connection exactly the same. Alright, so we do one, we fix it up in the properties, and then we propagate to everywhere we want it to go. Alright, now these beams here, so I want to connect this beam, hold control to this column, structure, connection. So I can come through, I can pick a connection, this one here. Alright, let's have a look. This is the actual connection that we do use. Alright, so what happens is they weld to the front face of the beam. They weld another haunch down the bottom here, and they bolt through the column. What this does is, if this starts to uplift and rotate about this way, this just helps the column bend. So it helps for wind and increases the flexural strength of the column. Alright, but again, in your structural drafting, you will learn all of that with me. So in here, again, we can override, and then we can start to modify, and we can shift where the bolts are sitting. What you can see is these bolts are very close to the edge here, right, the edge of this plate. So we'd shift them in, we'd shift them up and down, and we make some adjustments to it. Alright, but we're not going that in depth now. So right click, propagate, we should see one over here. Beautiful. So the next thing we need to do is we need to put in our base plates. So we click from the column, I want to connect the column, I want to connect it to the pad. Structure, connection. Alright, now I want a base plate, this one here. Alright, so what you can see is the bolts aren't sitting on the plate. So what I might do is override, modify. We can change all these, but you'll learn them later. So let's just make this, say 200 by 200. Let's change the anchors, so we don't use US anchors here. For these, we use a hold down bolt. Our structural grade, so we don't use 8.8 for hold down bolts, we use 4.6s. We use low tensile steel bolts. High tensile steel, 8.8s, they tend to snap when we try to move them. It's just the part of the construction sequence. When you've got the thread sitting through, we got to try to locate the plate and column on top of it. If we have to move them, they're not very good for that aspect. Alright, in tension, fantastic. When they have to move laterally, they tend to snap. And then we can change the diameter of the hold down bolts as well. We can change the length of how far it's sitting down here. So number 2 is the depth from the top to the bottom. Alright, that's this number here. Number 1 is obviously relating to the anchor diameter. Alright, tolerances, we went through that when we did our steel plates. So 2 mil tolerance for typical bolts. For our hold down bolts, 6 to 8 usually. is sufficient and per the code. Alright, so these ones here, we can't propagate. Alright, but what we can do is in level 1, I can copy multiple, so I can copy from here to here. Alright, so that copies it across to the other one. Now it's not going to be big enough for this one here, so let's just quickly whip up a connection here, and then I'll leave you guys alone. Base plate. Alright, so this one's a bit bigger now. We've got a bit of clashing with the bolts into the column. So we can modify, we can change some of these spacings. So if I change this here to say 200, alright, not enough. Sorry, I mean the anchor's parallel to the flange, so what I'm shifting is this way. Show 150. Yeah, it's a bit better. That plate is okay. What else are we going to change? Let's change these anchors again. Hold down bolts. Cool. Make that 500. It's good enough. Right. Cool. And then same thing from here. We can copy from this point to this point. Alright. And now we have 2 steel frames sitting up here. Obviously not engineered and designed. You will learn that down the track, and we'll go through it in structural drafting and in structural analysis. But that's a quick overview as to how we can put in some structural steel members. Alright. Thanks guys. Hope you're going alright with your projects and assignments, and I'll see you all on Thursday.